Hello guys, hope you all are doing well. So in the continuation of the previous GATE series, we were solving the questions of 1991 and today we have a new question and that is from solution thermodynamics and specifically the topic is chemical reaction equilibria. That is the last topic. And for thermodynamics, you can refer Smith as well as Kevin Narayana is there. And for solving this, these two books are for theoretical aspects. And for solving wide variety of numericals, you can go for Gopinath Haldar. Okay, but make sure Gopinath Haldar has few mistakes. So just go through it very carefully. Okay. So without wasting time, we will go to the question. So what question is saying? Calculate the fraction of pure ethane that would dehydrogenated at 750 Kelvin and 5 atmospheric pressure. Very first thing, note it down that atmosphere and bar is almost same. Okay, is almost same. And always remember in this specific topic, you have to take the pressure, total pressure, either it in ATM or either in bar. Okay. So we have the question has given the pressure in ATM. Okay. So what question is asking? Fraction of pure ethane that would dehydrogenated. That means the fraction of pure ethane that is converted to ethylene. Okay. If the following reaction goes to equilibrium, the reaction is given this del G, that it gives free energy, standard gives free energy. For the reaction is at 750 is this kilojoule per mole. Assume ideal gas behavior. Okay. Okay. So solution. So fraction of pure ethane that is converted to ethylene. We have to find this. Okay. At T equal to 0, before starting the reaction, suppose I choose it 1 mole. Suppose 1 mole of ethylene we are feeding to the reactor. But at the when the reaction is not starting, it will give 0 ethylene. Sorry, ethane. 1 mole ethane I am just giving to the reactor, and ethylene we are getting 0 and 0. Hydrogen also 0 because at T equal to 0, reaction is not happening. But at T at some time, the reaction started. And let E be the extent of reaction. E extent of reaction, that means the conversion. Okay, the conversion of the reaction. So in this particular topic, we represent conversion like extent of reaction. So suppose E be the extent of reaction. So according to the stoichiometry, hydrogen will be produced E and ethylene produced E. If there is like, if for example we have 2H2 or 3, just for example. Okay, so we will get 2H2 and 3 ethylene, just like that. Okay, so it is just an example. Okay, and suppose here we have 4 ethylene, so we will get here 1 we have fed minus 4 into extent of reaction that is reacted. So this 1 minus 4 into extent of reaction is reacted. So 1 minus 4 extent of reaction will be left. Okay, so this is just for example. Okay. Okay. So here, according to the stoichiometry, we are getting extent of E H2, E moles of H2, E moles of ethylene, and 1 minus E mole of ethane is remaining at the end of the reaction. So total moles of the reaction at equilibrium after completion of the reaction. This is the, just write it here as well, after completion of the reaction. So we will get 1 plus E. Now, so applying formula for extent of reaction, this equation we use Kp is equal to Ky into P ki power summation of nu, where summation of nu is the sum of the stoichiometric coefficient. For example, it is plus for the product and minus for the reactant. This one is for stoichiometric coefficient of H2 1. This one is for stoichiometric coefficient of C2H4 1, and the minus one is for reactant. Here it is 1. Okay, if it is 4, 3, 2, then I will write 3 plus 2 minus 4. Okay, minus 4. Okay, it can also come in negative. Okay, like this. So our job is to find Kp and Ky. So what is Kp? Kp is this. We can find Kp from here. This is the standard formula for standard gives free energy. Del G is equal to minus RT ln Kp. Okay, just rearranging the formula. Putting the value, we have del G, we have R, we have temperature, we will get Kp. This. Now, what about Ky? So, Ky is the mole fraction of the product divided by the mole fraction of the reactant. So, mole fraction of H2 will be moles at the end of the reaction divided by the moles, total moles at the end of the reaction. Got it? If I want to find out the mole fraction of H2, then moles of H2 that is produced divided by the total moles at the end of the reaction, and total moles at the end of the reaction at the reaction completion is 1 plus E. So, mole fraction will be this. Similarly, for C2H4, they will be this. Similarly, at the end of the reaction, 1 minus E of moles of ethane, pure ethane that is left, and that is the total moles that is at the end of the reaction. Now, putting all the values, Y of H2, product upon reactant, mole fraction of product upon mole fraction of reactant. So, Y of H2 into Y C2H4 and into Y C2H6. Now, here is a very important thing. Just listen carefully. If I have a reaction like this, 4, 3, consider this reaction, 4, 3 and 2. That means 4 C2H6, 3 C2H4 and 2 H2. Then always remember that on the mole fraction term, the stoichiometric coefficient goes to the power. For example, for this particular reaction, 4 C2H6, 3 C2H4, 2 H2, YH2 square will come. Okay, YC2H4 cube will come. And here power 4 will come. Right? But in the actual reaction, stoichiometric coefficient of all the components of all the reactant product is 1. Okay. So this is very important. We will see those questions later. IT Delhi in 2022 has asked that question. Okay. So there are so many. I just remember a few examples. Okay. So always remember this. So, but right now we have only stoichiometric coefficient as 1 of every molecule, every component. Okay. So we'll go further. Okay, now putting all the values here and 5 to the power 1, because 1 minus 1 will 0. So the summation of nu will stoichiometric coefficient, summation of stoichiometric coefficient will come 1. And I told you to put the pressure in ATM or bar. So yeah, in the question it is in ATM. So this is our final equation. Now we have to find E. So this is the final equation, just same as the previous one. Now just rearranging and mathematics. Okay, so we will get E equal to 0.0141. Now you can calculate mole fraction at the end of the reaction by putting value of E in this particular. Okay, you can find the composition. Okay. So hope you understand this question. This is very easy. Same concept when chemical equilibrium comes, same concept applies everywhere. And the very important part in this reaction is this. Many people don't know how to write this mole balance here. Okay, how to write this mole balance. So if you have any confusion in this mole balance, okay, I will tell you again, just comment it below if you find any difficulty in understanding this. Okay, so very accurately, at t equal to 0, we will not get any of the product. We just only have a reactant. At t equal to some time, some if I add 1 mole, then E will be the extent of reaction, then 1 minus E will be the moles left, and according to the stoichiometric coefficient, the same compound will form. That's all. Then at the total moles at the end of reaction will be this. Then mole fraction is just simple formula. Given moles, that is moles of the product, moles of the component divided by the total moles. That's all. Okay, so hope you understand this question. Okay, going to the second question. At 318 Kelvin, at a total pressure 24.4 kilopascal, the composition of system ethanol and toluene 2 at equilibrium. We will just go to solve the question by writing component 1 and component 2, not specifically in a name. So just remember, ethanol 1, component 1 is ethanol and component 2 is toluene. At equilibrium, x1 is 0.3, that means x2 is 0.7, y1 is 0.634, then automatically y2 equal to 1 minus 0.634. Saturation pressure at a given temperature for pure component. Okay, so we have P set for ethanol, P set for toluene. Okay, respect. Liquid phase activity coefficient, the value of gives the excess energy upon RT for the liquid phase. Okay. So very first, x1 is 0.3, y1 is 0.634. So summation of the mole fraction is always equal to 1. So we'll get this. Now, applying modified Rolle's law. Applied. For component 1, partial pressure of component 1 is equal to the mole fraction, activity coefficient of component, and pure saturation pressure of component 1. Partial pressure can be written as mole fraction into total pressure. Write it equation 1. This is very important concept. In 2014, IIT Kharagpur has asked a very good question on this topic, and I'll tell you we will solve those questions as well. And this is very important concept. You will understand this concept right here, right now, because okay. So for component 2, similarly, PA2, partial pressure of component 2 into mole fraction, activity coefficient into saturation pressure. Partial pressure I can write mole fraction into total pressure, and remaining term is this. Now, add 1 and 2. Add both these equations. What we will get? I added. Okay. YA1 and YA2, I just took out PT common. YA1 plus YA2 will be 1 because summation of mole fraction will be 1. So final equation will be this. This equation is very important. Okay, just remember this equation, write somewhere. This equation is very important. And GATE is asking from solution thermodynamics very specifically from this topic. Okay, now our job is to find the activity coefficient. So apply. First apply equation 1. So this is equation 1. This one. This. Similar equation. Put all the values, everything is given except activity coefficient. It will come 2.23. Second, same thing for component 2. Activity coefficient come 1.269. Okay, so we have found the first part. What about the second? Second part is, this is the general formula. Where is my cursor? Here. So this is the general formula, right? Xi, ln xi, where I tend to 1 to n for n component. But here we have 2 components. So x1 ln y1 plus x2 ln y2. So we will get this. So put all the values. Actually, I remembered the answer, but I have not calculated it. So I will calculate it to make sure that answer is correct or not. 0.3 into 2.236 ln plus 0.7 into 1.269 ln 40816. Yeah, actually when I was solving the previous year for my GATE preparation, I just remembered the answer. So it is right, 408. Okay, so these two questions we solved successfully, and I feel that you understand the concept. And if you have any doubt, just comment it below. I'll reply as soon as possible. Okay, if possible, I will upload my notes. Okay, so take care, guys. Bye. Bye.